Hey guys, so today we're going to be talking about integral test. So let's get right into it. So when a series doesn't fit cleanly into p-series or comparison, integral test is always your backup. Alright, so there's a rule people ignore, and I'll go over those. So I know this looks like a lot of words, but we'll go through each one step by step. So, you can only use the integral test if f of n is positive, f of n is continuous, and f of n is decreasing. Now, this is the most important thing. If those are true, then the summation from 1 to infinity of f of n and the integral from 1 to infinity of f of x dx either both converge or both diverge. Alright? So, you can only use the integral test if these three conditions are true. And that's a step a lot of people forget to check. So, we'll be going through one easy, one medium, and one hard example, and hopefully you guys will be masters at this by the time this video is done. So, let's first talk about why it works though. So just like close your eyes and imagine this with me. You're comparing the series to the area under a curve. That's what an integral is, right? The area under a curve. So think about it like this. A finite area is a finite sum, but then an infinite area is an infinite sum. That's all it is. Alright? So first example. You guys might know how to do this because of p-series, but let's pretend you don't. Alright? So define the function first. That's our first step. Well, so f of x, let's just make f of x equal to 1 over x squared. Alright, so now let's check the conditions. For x is bigger than 1, it starts at n equals 1. Obviously, it's going to be positive, right? There's a square. F of x is always going to be bigger than 0. Now, let's check our second condition, continuous. Well, the only way it's not continuous is if the denominator is 0, but we start at 1. So we're all good there. The denominator is never going to be 0. Now, decreasing. There's a bunch of ways you can do this. You can either plug in the terms, or you can just do first derivative and then check to see if the first derivative is negative. So let's do that. So f prime of x would be negative 2x to the negative 3. And so obviously this is a negative, right? We're starting at x equal, or n equals 1. It's going to be negative. So that means our third condition is correct. It's decreasing, it's continuous, and it's positive. So now we can actually do the integral test. So let's take the integral from 1 to infinity of 1 over x squared dx. And this would be, now we just do improper integrals. So limit as a goes to infinity of 1 to a, 1 over x squared dx equals the limit as a goes to infinity of negative 1 over x a to the 1. And then if you plug all this in, it's going to be 1. And that's a finite solution. So our answer is the series converges. Converges. And boom. That's all there is to it. I know it's a lot of steps, but it's important to kind of get the basics down. Eventually, you'll be able to eyeball it. You'll be able to tell, like, oh, obviously this is positive. Obviously this is continuous. And obviously this is decreasing. But for now, we're just going to go through step by step. Also, on your AP exam, when you're dealing with improper integrals, always make sure you have this line. They literally give you a point just for having this limit line. All right? Because you can't put an infinity here. Infinity is not actually like a finite number, right? So just keep that in mind. All right, next question. The summation is 1 to infinity of n over n squared plus 1. All right, so this does not look like a p-series, so the integral test is like a reasonable choice to go with here. So let's write it in terms of f of x. So f of x equals x over x squared plus 1. Alright, so now let's check our conditions. So is this going to be positive? Yes, obviously this is going to be positive. We're literally starting from a positive number, so it's just like there's no way for it to be negative. So first condition is done. Now second condition. Is it continuous? Well, the only way it's not continuous is if the denominator is equal to 0, but there's no way that the denominator is going to be equal to 0, right? Especially since we're starting at 1. So that part of it is true. So our second condition is true. Now last one, derivative check. Is this going to be decreasing? Well, obviously you can do the derivative, or you can kind of eyeball it and say, okay, well, this denominator is so much bigger than x, so the denominator is going to be growing much faster than x, which means this whole thing is going to 0. Or you can just do the derivative test, the first derivative test. So you would get, you'd have to use quotient rule, so it's kind of a little bit of a pain, but it'd be x squared plus 1 times 1 minus x times 2x over x squared plus 1. It's not necessary, right? You can tell it's going to be decreasing, but just kind of like a little sanity check. This would be 1 minus x squared over x squared plus 1 squared. As x is bigger than 1, the numerator is going to be negative, so the first derivative is negative, which means it's decreasing. That means all of our conditions are fulfilled, so now we can actually do our integral. So let me just erase this. And let's start with our integral. So the integral as 1 to infinity of x over x squared plus 1 dx. Now we do our limit. So limit as a goes to infinity of 1a x over x squared plus 1 dx. Alright, so now next step, we're going to have to use u sub. So u is going to be x squared. Let me use a different color to make it stand out a little bit more. Let me use orange. So u equals x squared plus 1 du equals 2x dx. So that means it would be 1 half, right? Integral 2 to a over 1 over u du, which equals 1 half ln of u, which is x squared plus 1, from a to 2. Now, if we, plug this all in, if we put in, right, a is what? As a approaches infinity, this is obviously going to go to infinity, so this is going to diverge, right? There's not a finite sum we're approaching, so this diverges. Boom. And on your AP exam, you'd write, since this improper integral diverges, then this summation diverges because all the conditions are met. But for now, we're gonna ignore all that because we're being a little bit lazy today. But right, that's literally all we're doing. Either both converge or both diverge. The integral diverge, which means the series is going to diverge too. So here's our last problem. This is a classic trap problem. So first let's write it in our f of x. So 1 over x ln x squared. Now, first condition, is it positive? Yes, x is never going to be negative. It's from 2 to infinity, right? And there's no negative sign in the denominator. So first condition, check. Second condition, is it continuous? Well, it's continuous if the denominator is not equal to 0. Is the denominator ever equal to 0 on our interval? No, right? X can't be 0, and this can only be 0 if x equals to 1, but we're starting at x equals to 2. So our second condition is met. Alright, so now we check our last condition. Is it decreasing? This is going to be a huge pain to differentiate, so let's just kind of talk through it. Yes, it's going to be decreasing because think about it. As x gets bigger, let's say x is 100, right? This is going to be super small. But now x is going to be, this function is going to be even smaller if x is 1,000,000. And then it's going to get even smaller if x is 1,000,000,000. So it's decreasing, right? Because there's a square in the denominator, but then we're also multiplying by that huge value of x. So it's decreasing. If you want, you could do the derivative and check to see if it's negative or positive, but it'd be super painful, and low-key, I don't think you'd have enough time on the exam to do that. So first, all three conditions are met. Sometimes you're going to have to kind of use a little bit of logic. You're not going to want to do the differentiation every time. Like this one, we did the derivative, but it was kind of a pain. We can see that it's going to be decreasing, but I just wanted to kind of show you out sanity check. But this one, this is like insane to do a derivative for, just for a simple problem like this. Alright, so All of our conditions are met, so let's do our integral. So it would be 2 to infinity of 1 over x ln x squared equals the limit as a approaches infinity, 2 to a 1 over, oops, this is dx, x ln x squared dx. And now we're going to have to do a little bit of u substitution. So our u, let me use orange again. So u would be ln x. And this is, you want to make sure you're really comfortable with integration when you're doing this. So it would be limit as a approaches infinity of 2 to infinity of 1 over u squared du, because the x's will cancel out. And then you would get negative 1 over u, which is ln x. Shoot, I keep forgetting the limit. You can't forget the limit, don't be like me. So limit as a goes to infinity of negative 1 over ln x from 2 to infinity. Now, we can kind of start putting it in. So if we put in infinity, ln of infinity is going to be infinity, and 1 over infinity converges to 0. So it'd be 0 minus, then we put in our second value using FTOC minus 1 over ln 2. What does that equal? 1 over ln 2, and that is a finite value, which means the series converges. Well, the integral converges, which means the series also converges. And boom, that's it. So, let's do a final summary. The integral test, you only use it if f of n is positive, f of n is continuous, and f of n is decreasing for a large number of n. Now, after that, you can evaluate the integral of 1 to infinity of f of x dx. And either both the integral and series converge, or both the integral and series diverge. So, simple. The hardest part, I think, is like the integrals. It's really easy to make a small mistake like that. Especially this, a lot of people kind of see infinity and assume like, oh, this diverges, right? But no, you have to actually plug it in and check. The reason wait. Oh my gosh. There should be an A. Sorry, we can't write infinity there. That's my fault. A. A. Alright, there we go. A. Alright. Anyway, the reason I didn't like explicitly plug it in here is because I did it in my head. What is going on? Did I forget an E? I didn't even spell diverge right. Alright, so I hope you guys enjoyed this video. If it helped you, leave a like, subscribe. If you have any questions or anything you'd like to see in the next video, any feedback, I'd highly appreciate it if you put them in the comments. I'll answer all of them. Thank you guys so much for watching, and I'll see you guys in the next video.